Hello, this is Dr. Lori. Welcome to this video on calculating a chi-square test of independence in SPSS. A couple of students have indicated that they would like a little help, so I decided to make a video on this topic. I have created a totally made up example of sugar intake and cavities, and you could perceive this as either a case control study or a cohort depending how the data was collected. It's not intended to represent either one of those specifically, but it does give you a 2x2 example of data that could exist. So here we have in our example, let me just make this a little bit bigger. In our example we have what I'm considering our exposure, either sugar intake or no sugar intake. And you could think of this as a bunch of little kids who either mostly eat fruit, so they are in the no sugar group, or they on a regular basis have added sugar to their diet. And then the dentist looks in their at their teeth, and they identify if they have one or more cavities, and these would be the ones that have cavities, and then the ones that don't have cavities would be in this second column. Now I want you to notice intentionally that I have put the exposure of interest, what I think is exposure, as this top row, and the outcome of interest as my first column. So the 5 is those who have sugar and do have cavities. So that's the exposure that I'm a priori thinking about ahead of time. If we were to put that same information into SPSS, the important thing to remember is that each row is a case. Each row is a person. And so I should have 5 rows of ate sugar and got cavities. And my variables are, did they eat sugar or not? And did they have cavities or not? So I'll have 2 variables in my data set. So this is what that looks like. Here's those first 5 people who ate sugar. So I coded ate sugar as a 0, and then cavities, yes, is a 0. I'm going to do something up here on the top section where it has this 1 to A, this little red button. If I click on that, what that does is it turns all of my coding. I coded 0 as sugar, so let me go ahead and put that in here. So, and cavities as 0. So you'll see the 5 ate sugar and got cavities are the first 5 rows. Remember, each row is a person. Each row is a case. Let me scoot this over just so we can see it at the same time. So here's those 5 people right here. If I could color code them over here, I would code these first 5 rows right here. Those 5 people had sugar, yes, and cavities, yes. Now the coding of 0 and 1 looks in this specific example opposite to what you would normally be used to seeing. Usually we code no as 0 and yes as 1, or at least you'll see that very often where they code it that way. But the reason that I've done this is that SPSS automatically numerically puts things in order based on what they're coded as, and in many cases it's not possible to switch it and choose which category is your reference category. So I've gotten in the habit of coding whatever my category of interest as 0 and the other category as 1. So let's go through this and you can see these other ones. Here are my 4 no sugar but still got cavities. So maybe they ate mostly fruit, they didn't eat excessive sugar, but maybe they didn't have very good dental hygiene and so they still got cavities. Here I have a sugar and no cavities group, so they ate lots of sugar but still did not have evidence of cavities when the dentist looked at their teeth. So maybe they had great dental hygiene and it overtook the effect of sugar. And then here we have our 10 no sugar, no cavities. And in a lot of countries where children don't eat a lot of sugar, we see great dental health. So this is kind of also something that we would expect to see. I'm going to go back to the coding here where we see the zeros and ones. And if I was to do a chi-square on this, that's pretty straightforward. I'm going to go to Analyze, Descriptive Statistics, Crosstabs. Crosstabs is essentially creating a 2 by 2 table or a 2 by 3 or 3 by 5 or anything like that. And I'm going to reset this because I already ran it once. My row variable here is sugar. My column variable is cavities, and I need to go to statistics and click on chi-square and continue. And I'll click OK. And here's my chi-square for that. And what you'll notice is that it creates a cross tabulation that should actually look exactly like what I have here. I have sugar cavities 5, no sugar cavities 4, sugar, no cavities 2, no sugar, no cavities 10. And so I should end up with that exact same configuration. Down at the bottom then, under the chi-square test, here's my Pearson chi-square test. I have a value of 3.5. The p-value, or what's called asymptotic significance, is 0.6. Or sorry, 0.06, which is not less than 0.05. And so I do not have a statistically significant result. However, this falls into the category of not meeting the assumptions, and so we'll actually have a chance to talk about that at a later time. And so we would use the Fisher's exact test instead. Gives us the same interpretation. 0.08 is not statistically significant, and so we make the conclusion that in this particular case we don't have any evidence that sugar is related to cavities. We don't have a large enough sample probably, and so we're probably making a type 2 error because we do have some pretty good scientific evidence that sugar intake is related to cavities. So that is the example for when your data is already entered into the computer. So here we have a data set that was already entered for us. However, you have gotten an example in your homework where the information was not yet entered into the computer. So let's go ahead and create a new data file. Here I am in Data Statistics, File, New, Data. So I'm creating basically a brand new data set. And what I need to be able to show you both of these at the same time. What you'll notice in your example is that you've been given the numbers, but it's not been entered into SPSS yet. And so, for example, I think you have 129 cases of a certain being in a certain wing of the hospital, and whether that person came down as TB positive or not. You probably don't want to enter 129 lines of data that shows that particular combination. This is intentionally a very small data set so that I could show it to you all on one screen, but you want to have some kind of a shortcut so that you don't have to enter 290 something lines of data. You could do that, but I'm going to show you a shortcut so that it will make this assignment faster, but I'm going to use the sugar and cavities example for that. So in data view, we're still going to have sugar as 0. So I'm going to build this from the ground up so that you can see me build it, and cavities as a 0. So let's go ahead and go to variable view now, and here I have my I need to enter that this is sugar and that this is cavities, and I'll put in my values that for sugar 0 equals sugar, 1 equals no sugar, And then for cavities, a 0 equals yes cavities, and a 1 equals no cavities. So now when I go to my data view, it will tell me that that's exactly what those particular specific cases are. I don't need to see it that way particularly. So that's one possible combination. Another possible combination is sugar, no, cavities, yes, and we have some of those in this particular side of our data. I need to be able to switch back and forth. So here's my 0 ones. There are 5 of them, remember? Those are the sugar yes, cavities yes. Here are my 1 zeros. Those are the sugar no, but still cavities yes. Here we have a possible combination of sugar yes, cavities no, and sugar no, cavities no. And so I've captured all 4 of these possible combinations. And see how there are 5 of the combinations that say 0, 0? I'm going to create a new variable that is my weighting variable called weight, as in W-E-I-G-H-T, not W-A-I-T. And I'm going to say I want to indicate somehow that there are 5 of those. And so this top row right here is going to represent my 5 rows in this particular data set. So in other words, I've compressed them down into one row, but I've created a new variable called weight. That allows me to just put all 5 of those into one row. The next row is the 1 zeros, or the no sugar but yes cavities, and there are 4 of those. So I'm going to put a 4 here. And then the next row is the sugar yes but no cavities, and there are 2 of those. And this final row, if you recall, there are 10 of them. So here's my 10 1-1s. If I were to look back, here's my sugar cavities 5, no sugar cavities 4, sugar no cavities 2, and no sugar cavities 10. So if I were to compare that to my original combinations, I would see that all of that matches up. The next thing that I need to do is I need to tell the computer what this weighting variable means. So if I go to data, at the very bottom, you'll see something called weight cases, and that's what we're doing. We're weighting them by this variable called weight. And when I do this, basically what happens is every time I do something now in the computer, now that that particular feature is turned on, the weighting cases, data weight cases, anytime anything is done in SPSS, it treats this row as if there are 5 rows here. It treats this row as if there are 4. If I make a graph, if I run an analysis, if I do any kind of descriptives or analytics, it treats this row as if there are 2 rows of that combination. It treats this as if there are 10 rows of that particular combination. So let's go ahead and in Analyze, Descriptive Statistics, Descriptives, Analyze, I wanted cross tabs. It's a habit. Cross tabs. I'm going to call sugar my row, cavities my column. So I'm doing exactly the same thing, but I'm using this data set now instead. And if I click OK, you'll see in my output window that I get the exact same cross tabs table. Remember, I said it will treat this row as if there are 5 of them, and there are the 5, 4, 2, and 10 if I did this properly. And then I should get exactly the same chi-square statistics. So what I've done is I have shown that this data set right here with 1 row per person, and this data set here with a weighted rows for each person. So this represents 5 people and this represents 4. This weighting variable has achieved the exact same thing when I'm calculating my chi-square test of independence. You'll have this same opportunity. Your exposure is different. For the example you're using, your exposure is which wing of the hospital those people were in, right or left. Your outcome is not cavities, but rather whether they came down with TB. So TB, yes or no, instead of cavities, yes or no. And your weights will be different numbers. And so when you calculate your chi-square, then you'll be able to see whether those two things are independent or whether they're related to each other. Thank you for joining me for this video. Have a fun time doing your assignment.